let's think about this. What is the limit x approaches infinity of 1 over x? The limit as x approaches infinity of 1 over x. If we can do this by table, lots of different ways. Just think about the numbers here. What this is saying, x is approaching infinity, infinity, is the x values are getting larger and larger and larger. So x equals 10, pretty big number, but x is 100, x is 1,000. What's happening to these values as x gets bigger and bigger and bigger? Aren't these going to something? What are they going to? They're going to 0. Yep. So it turns out that the limit as x approaches infinity of 1 over x is 0. All right. What about the limit as x approaches negative infinity of 1 over x? Does that change it? Well, if I go x goes to negative infinity, negative 10, negative 100, negative 1,000, 1 over x does what? It's 1 over negative 10, 1 over negative 100, 1 over negative 1,000. Does that change anything? I don't think so, because those are still going to 0, aren't they? Yeah, that's still 0. Either way, as you go to infinity, 1 over x is going to 0, either infinity, negative or positive. All right, what about x squared? Well, yeah, x squared. Let's don't make a whole other table here. If we're going to x squared, 1 over x squared, if we're going to infinity, let's just do this. Well, that's going to 1 over 10 squared, 1 over 100 squared, that's going to, and that's going to 1 over 1,000 squared. That's still getting closer and closer to 0, isn't it? Matter of fact, it's getting closer and closer to 0 faster, I guess you might say. But either way, it's still 0. I think you get the idea here. If you go to negative infinity of 1 over x squared, that's still 0. If you do the limit as x goes to infinity of 1 over x cubed, that's 0. Yeah, anytime you have 1 over the variable to a power, or just not, just x, the limit as x goes to infinity is 0. That's an important little note. Matter of fact, what if I put a number on the top? What if it was the limit as x approaches infinity of, let's say, 500 over x? Is that going to change it? Different ways you could see that, but if you just put in the numbers in your table there, is that going to change anything? Doing 500 over x, so that would be 500 divided by 10, which is 50. You'd have 500 divided by 100. That's 5. 500 divided by 1,000. Well, you might have to go out a little bit further to see. So that's a half. If you do 10,000, whoops, ran off my chart here. 1,000 was 500 divided by 1,000. That's 1/2. We go to 10,000. That's 500 divided by 10,000. Well, that's 1 over 20. Same thing's going to happen, and I just have to go a little bit further out maybe to see it. That's still going to be 0. So it really doesn't matter if you have a number on top or you have a variable to a power on the bottom. If you have the limit as x approaches infinity of, say, some k divided by x to some power, squared, cubed, that sort of thing, it's going to be 0. Any number on top here, any power, positive power, let's say, yeah, that's going to be 0. So that's going to be handy. Here's how it comes in handy. Let's think about the limit of x going to infinity of some more complicated looking functions. Let's say we've got the limit as x goes to infinity of 3x squared minus x minus 2 over 5x squared plus 4x plus 1. Now, again, this is different than what we were doing before because we're going out to infinity. X is going to infinity. Doing a limit, this is a limit at infinity. If you have that, here's what we're going to do. Because of what we just worked on, we know if I can get some things where I have something over x to a power, just x, those go to 0. Here's what I'm going to do. I'm going to divide, look at your bottom denominator here, divide the top and bottom by the largest degree of x in the denominator. Divide the top and bottom by the largest degree x in the denominator. Which in this case is x squared. So I'm going to divide the top by x squared and the bottom by x squared. Okay, so writing it all out the first time here. Show you what I'm doing. 3x squared, I'm dividing that by x squared, minus x, divide that by x squared, minus 2, divide by x squared. Doesn't that divide the top by x squared? Then the bottom, also divide everything by x squared. Now, of course, some of those simplify. On the top, the x squared is canceled, so I just have 3 there. That one simplifies. That'll be what, 1 over x there? That one simplifying. The x squared is canceled there, so that's 5. That would be 4 over x, and that would be 1 over x squared. Remains as 1 over x squared. Why did I do that? Well, as we know, limits, if you get it like this or something like this, limits are nice because you can just separate the limits. I can do the limit of this minus the limit of that, minus the limit of that, over the limit of that, limit of that, limit of that. But I'm going to write all that out. Here's the thing. What is the limit as x goes to infinity of that? That's 0. What's the limit as x goes to infinity of that? That's 0. That goes to 0. That goes to 0. Everything goes out except to 0. This one. So this winds up being the limit, anyway, 3/5. That's what you can do if you're doing x goes to infinity. So you don't have to factor. You just have to divide top and bottom by the largest power degree of x you got in your denominator. Okay? Not too bad, right? Okay, what if what if it was this? The limit as x goes to negative infinity of x squared minus 3 over x cubed plus 4x plus 3. Again, we're doing a limit at infinity, so let's divide top and bottom by the largest degree. What would that be here? X cubed. So divide top and bottom by x cubed. What does that get me? Well, that gets me limit as x goes to negative infinity. X cubed divided by x squared divided by x cubed minus 3 divided by x cubed. And then bottom, same thing. That gets me the limit as x goes to negative infinity of 1 over x minus 3 over x cubed, 1 plus 4 over x squared plus 3 over x cubed. The things over x all go to 0, so this is 0 minus 0 over 1 plus 0 plus 0, isn't it? What does that get you? Is that okay? Everything like that? Yeah. That limit's going to be 0. So in this case, you wind up with 0 over 1, which that's okay. That's still 0. All right. Now, mention this one. Something slightly different happens here. Say I've got x, limit as x goes to infinity. It's x to the 5th minus x cubed over x to the 4th plus 2x squared minus 7. First point about this one, let's get that written down. X to the 5th minus x cubed over x to the 4th plus 2x squared minus 7. Now, what do I divide this one by? Be x to the 4th, yeah. You do the largest degree in the denominator. So I'm divided by x to the 4th. I know I have a larger degree in the top, but for this to work or to show us what we need it to show, divided by the largest degree in the denominator. So divide by x to the 4th. So divide the top by x to the 4th each, the bottom by x to the 4th. And how much ever you need to show there, but here's what I get. I get the limit as x goes to infinity of x minus 1 over x, and then 1 plus 2 over x squared minus 7 over x to the 4th. Okay. That goes to 0. That goes to 0. That goes to 0. But I still wind up with the limit as x goes, wouldn't it be the same as that? Because the rest of them are just zeros. What about that? The limit is just infinity. That's right, because this goes to infinity, so I've got infinity basically divided by 1. Well, that's still going to be infinity. Yeah, so that one's a little different. When I do the dividing, I still wind up with an x basically in the top. So when that happens, yeah, you got a little something different there. Now, let me slightly change this and make it limit as x goes to negative infinity. Same thing. X to the 5th minus x cubed, x to the 4th plus 2x squared minus 7. So everything stays the same, but I wind up eventually, divide by the x to the 4th, same as that. So I eventually wind up with that. But I'm going to negative infinity, so this goes to negative infinity. So is it still infinity? No. X is going to negative infinity, so this changes up to negative infinity. Is that okay? All right, one more of those, because that's a little bit tricky. What if we're going to negative infinity, and it's x to the 4th minus 16 divided by x squared plus 5. Well, what do I divide by? X squared, top and bottom by x squared. Like I said, how much ever you have to write here, but I would like to show some of this, but divide everything by x squared. Okay, so that's going to give me the limit as x goes to negative infinity. That'll be x squared. That'll still be 16 over x squared. That'll be 1 plus 5 over x squared. Well, these two goes to 0. That's good. So I wind up with limit as x goes to negative infinity of x squared over 1. Well, does that go to negative infinity? What does it go to? It goes to positive infinity because why? I'm squaring the x. So yeah, we've got to think about plugging in larger and larger negative numbers, more and more negative numbers, let's call it. But I'm squaring them. When you square a negative number, you get a positive number, don't you? So the x goes to negative infinity, but then when I square it, I'm going the other direction. I'm going to positive infinity. So this one's positive infinity. So you just have to see what the numbers, things bear out there. Okay. Now here's something else that well, let me mention this. This is kind of tied in. All right, so let's say the limit goes x to let's say I wind up with with that. What about that? Well, there's no, there's nothing to divide there, and there's not any trick. There'll be a couple of tricks that we're fixing to talk about, but this one doesn't have. You just have to think about it. If I'm going to negative infinity, that's going to be infinity squared. But if I go to infinity for that, well, here's the thing. The largest, if you run into that, the largest power dominates. This is going to take precedent, or take control, if you will. Because this, technically that would go to negative. But if you think about it, just think about the graph. As you look at the graph of that, that's a parabola that opens up. So it's going to infinity. So the thing is, this one, the largest power term, if we get something like that, dominates. So it's going to go to infinity. Forget the minus 4x. So I just wanted to mention that if it happens to come up. All right? Okay. But there are a couple of other little tricks to these limits of infinity, if we have some square roots involved anyway. Limit as x goes to infinity, and it's going to be the top is 2x squared plus 1 divided by 3x minus 3x minus 5. What are we going to divide there by? Well, the top. The top is, the degree of the bottom is the one I divide by, right? So divide by x. Now, what I need to note, though, is I am dividing the top by x, but the top is a square root. And so I can't just divide that by x inside there because, it's a square root and the x is not a square root. So what I need to do is make this x into a square root. How can I make x into a square root? Well, what does x equal in terms of a square root? Doesn't x equal square root of x squared? Does that make sense? Would you believe that? Yeah. X is equal to the square root of x squared. If you're going out to infinity, we'll have to think about that just a second. But that's how we're going to do it. If you've got a square root, you need to divide into. Yeah, change your variable into a square root. And for x, it's just the square root of x squared. So divide the top by x, but in the form of x. Here's what I'm saying. So I'm going to divide the top by the square root of x squared. Now these are just same old, but you see, then I can combine these. You see, now it's the limit as x approaches infinity of 2x squared divided by x squared and 1 divided by x squared. So you see the x came inside as x squared because it's square root. 3 minus 5 over x is here. Well, that makes it what? Limit as x goes to infinity. It's 2 plus 1 over x squared up here in the square root. See what happens? That's going to go to 0. That's going to go to 0. So I wind up with the square root of 2 over 3, don't I? And that is the answer. Now there is a slight little problem. Let's talk about that. If your x is bigger than 0, yeah, x is equal to the square root of x squared. Because think about it, if your number, say we're 7, x is 7, doesn't that equal the square root of 7 squared? Yeah, it does. Okay, so that's true. However, if x is less than 0, let's think about that. What does x equal there? Well, if x is, talking about a square root here, if x is negative 7, then is it true that, is that true? No, because that's the square root of 49, which is 7, positive 7. So to get it to equal to negative 7 this, I've got to put a negative out there. Because that would be true, wouldn't it? This is negative the square root of 49, which is negative 7. So those match up. So the thing is, if your x is less than 0, negative, you got to do x is equal to negative the square root of x squared. You with me? Why do I bring that up? Well, let's think about this one. I don't know if it's the exact same thing, but yes, it is. Okay. All right, so if I'm doing the limit as x approaches negative infinity of the square root of 2x squared plus 1 divided by 3x minus 5, that's not quite the same. Because what are the x values here? Well, they're negatives. I'm going out to negative infinity, so I'm talking x is less than 0. So when I divide this by x, and I divide this by x, x is not going to be the square root of x squared. It's going to be what? It's negative the square root of x squared. So I'm going to divide top and bottom by negative the square root of x squared. And so that'll get me, so I'm taking the top, dividing it by negative square root of x squared. Of course, the bottom is just x, so there's no problem there. Okay, you with me? This one, the top, I have to divide by negative the square root of x squared. All right, so what does that do? Well, the negative just kind of stays out there. It'll be 2 over x squared, so that's 2. 1 over x squared, that's 1 over x squared. 3 minus 5 over x. That goes to 0, that goes to 0, so I wind up with about the same answer, but it's negative. Negative the square root of 2 over 3. How about that? Okay. So that's one square root problem there. What about this one? Limit as x goes to infinity. And we've got the square root of x squared plus 1 minus x. Well, to kind of show it, there's a trick here we can do on this one. It's using a conjugate. Because I don't notice here I don't have a denominator, so that rules out for the time being anyway doing our little divide by the degree thing. And what you're going to do is start here, multiply by the conjugate. And we're going to treat that as over 1. So I'm going to multiply the top and bottom by the conjugate of square root of x squared plus 1 plus x. The conjugate is. See what happens there. All right, so that makes the limit as x goes to infinity. What happens? Well, that times that, square roots go out, right? It'll just be x squared plus 1. The middle terms, well, you got an x, square root of x squared plus 1, and then you got a minus x, square root of x. Those cancel out, don't they? So then I'll have minus x squared as well. Then on the bottom, well, I'll just have square root of x squared plus 1 plus x. Well, nicely, these go out. So I have the limit x goes to infinity of 1 over square root of x squared plus 1 plus x. Which is better because now I've got a denominator, and so what do I do when I have them like this? Limits at infinity for this. I divide by the largest degree in the denominator, which, if you think about it, that is x to the first, and technically that's also, because you got the square root of x squared, that's also x to the first. With me? So I'm going to divide top and bottom by x. So that'll get me the limit as x approaches infinity of 1 over x over, now, when I divide this by x, I'm actually going to divide by what? The square root of x squared. So that's going to come in as x squared, so that'll be the square root of x squared over x squared, which is 1, plus 1 over x squared. That'll be x over x, which is 1. What have I got? Well, that goes to 0, so the top is 0. That goes to 0, so I've got the square root of 1 plus 1, which is the square root of 0 over 2, which is 0. So, yeah, it turns out, in that case, limit at infinity, x goes to infinity is 0. Way to prove that out.